Welcome to this new video of one shot series. In this video, we are going to cover continuity and differentiability at the level of board exams of class 12th. So what I have done in order to make your life extremely easy is I have divided this topic into 9 problem types that are asked on the topic of continuity, differentiability and differentiation. I am going to take the theory of each of these 9 types and discuss them in brief, then move on to the problem type and cover all the different types of PYQs that are asked on that problem type. So in this manner, you will not just be able to understand what kind of questions were asked in a very categorical manner, but you will also understand the theory behind it and the technique to solve those questions. So without any further delay, let us start with it. So if I look into the first concept, this concept is that of continuity. So now what is continuity? In order to simply understand it, continuity is nothing but if I can draw the graph of any curve without lifting the pen. In that scenario, we are going to call that function as a continuous function. Something like this. Now, if I want to write it down, what is the condition for it? So a function would be said continuous at a point A if left hand limit at that point is equal to value of function at that point is equal to right hand limit. Or in other words, we can write it as limit h tends to 0, f of a minus h is equal to f of a is equal to limit h tends to 0, f of a plus h. Now we should understand this. In order to understand this chapter and this problem type, you need to have some basic knowledge of limits. So I will highly recommend that you revise your limits part before jumping into the idea of continuity and differentiability. Now, once we have understood this idea, now let us see what kind of questions are asked on continuity. So now this 2023 question talks about the value of k for which this function is continuous. Now, since it is an objective question, we can have a shortcut for solving such questions. So what you can do here is take this value of 2 and substitute here in this part. Take this value of 2, substitute in the other part. So what we are doing is we are trying to find the LHL, and it is nothing but limit h tends to 0, f of 2 minus h. Now when you are taking a value of x less than 2, you'll have to use the second part of the function. So here what we can do is we can put this as k into 2 minus h whole square, and since it is a determinate limit, I can directly substitute the value of h as 0, and if I do it so, this becomes nothing but 4k. Similarly, if I want to find the value of RHL, what I can do is limit h tends to 0. This I can write. And f of 2 plus h we will have to find. Now, in order to find this, it is very simple. Now, we are going to use the part of this function which is for which x is greater than 2. That is the first part. If I take this function, it is 3 times 2 plus h plus 5, and if I put h equal to 0, since again determinate limit, this becomes nothing but 6 plus 5, and that is nothing but 11. You can see that for this function to be continuous, LHL should be equal to RHL, should be equal to value of function at 2. So if I do this, what you will get is your 4k will be equal to 11, and if I do so, the value of k comes out to be 11 by 4, and if I look into my option, it is nothing but option D. So extremely simple question. Now I can also do it very fast, and just by doing this one step, and this is another method of doing this question. What I could have just done is put the value of 2 here, so this becomes nothing but 6 plus 5, that is nothing but 11. Put the value of 2 here, it would become nothing but 4k. And then we can compare both of these values. So 4k is equal to 11. So k comes out to be 11 by 4. Now this is an objective method for solving an objective question. If you want a subjective approach, this is a subjective approach. Now if I look into another question of 2017, this is a subjective question. So I will have to use the subjective approach to solve it. Talks about the value of k for which the following function is continuous at x equal to 3. Now what is the condition of continuity? It says that LHL should be equal to RHL, should be equal to value of function at that point. So we'll have to find the value of LHL. It comes out to be limit h tends to 0, f of 3 minus h. And now if I do so, what am I getting here? This becomes nothing but 3 minus h plus 3 whole square minus 36 by 3 minus h minus 3. Now here you can see that what is happening is I'm using the other part of the function, because this is only valid for x equal to 3. Here x is not equal to 3, we're looking at the value of function at its value slightly less than 3. So that is the reason we'll have to use the first part. Now if I solve this limit, so what I can get is limit h tends to 0. This becomes nothing but 6 minus h whole square minus 36 can be again written as 6 square. This will become nothing but minus h. And again, if I simplify this part, you can see that this becomes limit h tends to 0. I can apply the formula of a square minus b square. So a square minus b square is nothing but 6 minus h minus 6. And then 6 minus h plus 6 divided by minus h. 6 and minus 6 will get cancelled out. Minus h will also get cancelled out. And I will put the value of h as 0. And if I do so, this becomes 12. This is what we are getting. We can similarly find the value of right hand limit also, and it is highly suggestible that you do that, because sometimes it can happen that LH and RHL might not come out to be equal and there is no real value of k that might be possible in that scenario. So it is highly recommended that you figure out the value of left hand limit and right hand limit both. So in this case, if I figure out right hand limit, it comes out to be, I will put 3 plus h in this place. So this becomes 3 plus h plus 3 whole square minus 36 divided by nothing but 3 plus h minus 3. And if I simplify this, it becomes limit h tends to 0. 6 plus h whole square minus 6 square by h. And once you have done that, we will use a similar kind of process we'll use in the earlier part. Limit h tends to 0. This becomes 6 plus h minus 6. 6 plus h plus 6 divided by h, and this will get cancelled out. H will also get cancelled out. And what we get as answer is nothing but 12. You can see that left hand limit is equal to right hand limit. So now we'll apply the condition LHL is equal to RHL is equal to value of function at that point. If I apply this condition, this comes out to be nothing but 12. Value at 3 comes out to be k. So value of k comes out to be 12. Similar kind of question, but now in subjective form. If I move further, the next type of problem is nothing but based on differentiability. So for finding differentiability, what you need to know is basically what does differentiability means. So fundamentally, differentiability means that whether the function has an existent rate of change or not. In simple words, most of the times the curve will have a sharp turn, something like this, or the curve will become discontinuous, something like this. So it would be a point of discontinuity. So let us write discontinuity, and or it would be nothing but a point of sharp change like this. In other words, if I want to write it algebraically without graphs, what we can understand is the concept says that LSD should be equal to RSD. Now what is LSD and RSD? If I write my LSD, or right left hand derivative, it is limit h tends to 0, and we are checking this at a point A. So if what I can write is f of a minus f of a minus h by a minus h. So you can see that whatever we are writing here, we are subtracting in the denominator as well. So essentially this also denotes the slope of the curve at that point. So if I do that much, this simplifies into limit h tends to 0, f of a minus f of a minus h by h. Similarly, if I want to find RSD, it is nothing but limit h tends to 0, f of a plus h minus f of a by a plus h minus a. You can see that again the similar idea is coming. Whatever we are writing here is here, whatever writing here is here. So once we simplify this, this becomes limit h tends to 0, f of a plus h minus f of a by h. Now what you can observe from here is basically, if I draw the curve and understand the idea graphically, if this is a point a comma f of a, what we are saying is if there is a point here that is a minus h comma f of a minus h, and on the right hand side we have a point a plus h comma f of a plus h. So what we are saying is if I find this small secant slope on this side and this side, it should come out to be equal. And if it comes out to be equal, what will happen is it will be a smooth curve. And that smoothness of the curve will mean that at that point, the tangent has one slope, or in other words, the function's rate of change exists and is equal to nothing but the value of LSD and RSD at that point. So the condition for a function to become differentiable, or the rate of change should exist, is nothing but LSD should be equal to RSD should be equal to a finite value. If this condition gets satisfied, we will be able to say that the function is differentiable. Now let us see what kind of questions are based on this idea. So if I look into PYQ 2023, a question came and says the value of k for which this function is differentiable at x equal to 0. Now, first I will tell you the subjective approach, and then I will tell you the objective approach. If I look into the subjective approach, how does it looks like? We are going to find LSD at x equal to 0. They have also given us the point. So earlier continuity and here differentiability, both we are checking on a point. This is a very important idea that you need to note. So if I apply my concept, it is limit h tends to 0, f of 0 minus f of 0 minus h. So instead of a, I have written 0 by h. And if I write it down, it becomes limit h tends to 0, f of 0 will come from here. So if I put 0 here, I should get my answer. So this is nothing but 0 square. And minus h, if you are looking into the function's value, will come from the other part. So this becomes k into 0 minus h by h. And if I simplify this, you can note that this becomes limit h tends to 0, kh by h, and k will get cancelled out. The answer becomes, sorry, h will get cancelled out. The answer becomes k. Now similarly, I can also find the right hand derivative. Let us also do that. If I have to find RHD, or right hand derivative, the answer becomes limit h tends to 0, f of 0 plus h minus f of 0 divided by h. So if I put the value 0 plus h will again be obtained from here only. So if I put the value here, so it becomes nothing but h square. This becomes 0 by h. And if I simplify, limit h tends to 0, h square by h and h will get cancelled out. And if I put the value, it becomes 0. You can see that we have figured out LSD, RSD, and finding LSD, RSD is all based on limits. So you need to revise your limits before going into this chapter. Now, once you have done that, the condition is very simple. LSD should be equal to RHD is equal to a finite number. Now you can see that this number is already finite. It is 0. So here RSD has become 0. LSD has become nothing but k. So k becomes nothing but 0, and that is nothing but option D. Now, if I want to do this question in a much shorter manner, then there is this concept of derivatives or differentiation that we can use in this case. So what is the shortcut method or an objective method to do this objective question? Since it is objective, I'm telling you the objective method. Otherwise, you can use a standard method. So what you can do is you can find the value of f dash of x. So if you differentiate this to x square, it becomes 2x. If you differentiate kx, it becomes k. This is for x greater than 0. So we have removed the equal to sign. Now what you need to do is, in order to find LHD, it is very simple. Just put x equal to 0 in this part, it becomes k. For finding RHD, put 0 in the other part, so it becomes nothing but 0. So directly you are getting the same answer that we earlier got using that many steps. So it is fine. Now see, in order to apply this, there is a prerequisite. What is the prerequisite? The function needs to be continuous. But since they have told us that differentiable at this point, differentiable functions are continuous in nature, so that is already applied. So this technique also, or shortcut, you can also use in getting the answers really fast. Now let us move on to this 2023 question. It talks about the function, and what they're saying is this function is again an objective question, so an objective approach we can use here. What you can do here is you can draw the graph of this function, that is mod of x. This is how it looks like. So graphically what I told you was, if there is a sharp turn, at that point the function is not differentiable, or the function breaks out. So it is discontinuous, it is not differentiable. If there is a sharp turn, it is non-differentiable. So you can see that wherever I draw this curve, it is a smooth curve I can draw in a single stroke of pen. So obviously it is continuous. So it is continuous everywhere. But if I talk about differentiability, it is non-differentiable at 0, only at this point. Now let us see the options. So if you are looking to this C option, continuous everywhere, differentiable everywhere except x equal to 0, this comes out to be the right answer. So just by drawing the graph, you can write the answer to this question in 30 seconds. If I move forward, there is this 2020 question that talks about greatest integer function between 0 to 2. And you can see again it is a fill in the blank, so I do not need to show my process. So my graphical approach will again work out in solving this question. So if I draw the graph, let us see how it works out. The greatest integer function graph between 0 to 2 will appear something like this. So this is 0, 1 and 2. What they are saying is talking about values between 0 and 2. So even 0 and 2 are not included. So what we need to check out is add in this portion, is it not differentiable anywhere. So I have told you that there are two conditions, sharp turn or the curve breaks. The curve is breaking at x equal to 1. So at x equal to 1, the function will become non-differentiable. So wherever the function is discontinuous, it is non-differentiable in nature. Now let us look into this 2023 case study that was given. They have defined what is LSD, RSD. So this is by definition. They have already given us the definition only. Nothing very specific about this. Now they have given a function, and what they're saying is LSD and RSD exist and both are equal, fine, for this function. Then what is RSD of the function at x equal to 1? LSD at x equal to 1. Check the function is differentiable at x equal to 1. And then they are talking about derivatives. Okay. So this is an interesting question. And since it involves writing steps, I will highly recommend that you only use LSD RSD method. The derivative method will get some marks deducted, and also the graphical method is correct, but sometimes you will get some marks deducted. And also it is not that simple to draw the graph of this function. Student who is just preparing at the level of boards will find it difficult. JEE students can draw it really fast. So if I look into this question, let us write it down. So what you can do is you can, in the first step, understand what the question is saying. So question is given as a function, and first I am doing is I am reinterpreting the function, and I am trying to remove the value of modulus here. So what I will do is I will take this function, and in order to remove the mod, see if I put the value of x greater than or equal to 3, this mod will open with a plus sign. If I put values smaller than 3, it will open with a negative sign. And then this value is only happening for values greater than 1 but smaller than 3. And the rest of the function is given to us x square by 4 minus 3x by 2 plus 13 by 4 for the values of x smaller than 1. This is what I have done is I have reinterpreted or removed the modulus sign. This is a very important step, because by taking this step, the modulus that will cause a lot of problem to you is already gone. This has become a simpler question now. So how to do it in the next step? What you are going to do next is find the value of RSD at, this is our first part. So RSD if I find at a point 1, limit h tends to 0, f of 1 plus h minus f of 1 by h. So if I take this value, f of 1 plus h, if I take the 1 plus h will go into this middle part of the function. This part, it will go here. Here it will go. So now let us see this. So if it goes here, so function I am going to use is minus of 1 plus h minus 3. And 1 if I have to put again, it will go in the same part. So it will become minus 1 minus 3 by h. You can see that what is remaining here is limit h tends to 0. This will become 2 minus h. And this is again nothing but minus 2 by h. So minus 2 and 2 gets cancelled out. So the answer comes out to be minus 1. This is the answer to the first part of the question. Let us write this as part 1. If I look into the part 2, what they are asking is the value of LSD. So now let us see how to find the LSD of this function. So LHD is nothing but limit h tends to 0, f of 1 minus f of 1 minus h by 1 minus 1 minus h. If you write it in this manner, it is very simple to remember also and write also. So now if you take the value function at 1, we have already figured that out. It came out to be nothing but this. So let us find that value. So if I take that value, it came out to be 2 minus. And now if I take 1 minus h, you can see that now 1 minus h in this scenario will go into this part where the value of the function is smaller than 1. So if I take this part, it is nothing but x square by 4 minus 3x by 2. So this is x square. So 1 minus h whole square by 4. Second part is nothing but 3x by 2. So minus 3 into 1 minus h by 2. And then the last part is nothing but 13 by 4. By nothing but this will become h. So now we need to find this value. So let us figure it out. So if I put limit h tends to 0, this becomes 2. And again, if I take LCM, 1 by 4 can be taken outside. It becomes 1 minus h whole square minus 6 into 1 minus h plus 13 by h. And the fourth part, what they're asking is nothing but the derivative of this function. And this is our fourth part. So now the fourth part, if you want to find derivative, we'll differentiate this function. It becomes f dash of x. And if you do so, the differentiation of first part becomes 1. The second part becomes minus 1. So this is for greater than 3. This is for smaller than 3. And then this becomes nothing but 2x by 4 minus 3 by 2. When x is, this is between 1 and 3, this is smaller than. So now if I want to find the value of f dash of 2, so what I will have to do is, in order to find f dash of 2, we will have to take the interval where 2 lies, and that interval is nothing but this middle interval. So you can clearly see that it values becomes nothing but minus 1. If I want to find the value of f dash of minus 1, you can see that for finding minus 1, we'll have to go in this region. If I go in this region, all I need to do is put the value of x as minus 1. So this becomes minus 2 by 4 minus 3 by 2. So it becomes minus 1 by 2 minus 3 by 2 minus 2. And this is the value that we are getting. They have answered all the parts of the question. And you can see that 99% question, in fact 100% questions in board can be done just by finding the value of LSD and RST. Now if I move forward, let us see the next problem type. The next problem type talks about algebra of differentiation. Now you can see that we have completed the continuity part, LHL, RHL, value function at point, differentiability part, LSD is equal to RSD is equal to finite value. Now we are moving toward the idea of differentiation. And if I talk about algebra of differentiation, we have these rules that we need to take into consideration. So if we have function, let us write u and v. So u plus v, and if I am doing derivative of this function, then the answer is the derivative, sum of derivatives of individual function. So, and if I am putting a minus sign and putting the derivative, then u dash minus v dash. And then if you have multiplication, we have nothing but the product rule. So u dash v minus u v dash. And then again u by v dash, we can write as nothing but u dash v minus u v dash by v square. Now, these are the 4 rules that we have. So what we are saying in simple words is, if I take two functions, let us take the value of u as nothing but x square and v as nothing but sine x. So what we can write is, in the first part, what it talks about is differentiation of x square plus sine x. If I want to find, it will get distributed. So d by dx of x square plus d by dx of sine x. So you can see that the answer becomes 2x plus sine plus cos x. If I have nothing but the difference, then x square minus sine x will come. Again, it will get distributed. So d by dx of x square minus d by dx of sine x will come. And again, the derivative of x square is nothing but 2x. The derivative of cos x sine x is nothing but cos x. So this is what we are getting. Now, if you want to find that for the multiplication, so if you have x square into sine x, then what we are saying is we'll find the differentiation of whatever is the first function into, we'll multiply the other function, and then we'll put plus sign, write the first function and the derivative of second function. So we'll write x square here and derivative of the second function, that is sine x. If I do that, this becomes a 2x sine x, then x square into cos x. This becomes our answer. So we have understood what to do in the case of addition, then subtraction, then nothing but multiplication. Now let us move towards the idea of division. So in the fourth part, if I want to find the derivative of x square by sine x, I can use my quotient rule or the division rule. So what does it say is you differentiate the numerator and then multiply denominator with it, then put a minus sign, write the numerator and differentiate the denominator and multiply with it and divide the whole thing by the square of denominator. This is what it means. If I do so, the numerator becomes 2x into sine x minus x square into cos x, and the denominator becomes nothing but sine square x. So this is the answer. So there are these four very important rules of addition, subtraction, multiplication, and division that you need to keep in mind while solving this kind of problems. If I look into this 2023 question, it talks about application of algebra of differentiation. Now, before applying this concept, what you should understand is there are two steps. One is simplification, and the second step is nothing but differentiation. So there are two steps into it that you need to understand. So first, let us simplify this. So you can see that what we can do here is we can divide it by cos. So this becomes 1 minus sine x by cos x. The denominator also becomes 1 plus sine x by cos x. And now this is a question of trigonometry in class 11. So trigonometry is very much linked to calculus part. So this minor trigonometric manipulations will come. Now this part, 1 that is in the numerator can be written as 10 pi by 4 because it is also equal to 1. And here we can also write along with 10x a 10 pi by 4 because it is equal to 1, won't make any difference. Once you have done this, you have got the formula of 10a minus b. So this becomes 10 pi by 4 minus x. This we have got. So once you have got this, the next part would be to differentiate. You know, this is the first part that we have done. So in the second part, what we can do is we want to find the derivative dy by dx. It is nothing but d by dx of tan of pi by 4 minus x. So if I differentiate this, it is nothing but tan x differentiation is nothing but sec square pi by 4 minus x. And then applying chain rule, I will also have to differentiate this part. The differentiation of this part becomes minus 1. So answer is nothing but minus of sec square pi by 4 minus x. Now let us check the options. You can see that your option A comes out to be true. So always remember that directly differentiation will make the question of algebra difficult. First simplify and then differentiate. This is a very important trick and will be useful in solving a lot of questions. If I move ahead, the type 4 is nothing but application of chain rule. So now first understand what is chain rule. So chain rule is used first in the context of a composite function. So I will take an example to illustrate and then we will write the general formula. So if I have nothing but sine of x square, this is a composite function consisting of two functions. So what we have is there is a function fx that is nothing but sine x, and there is a function gx that is nothing but x square, and what we are writing is f of gx. If I write f of gx, it becomes nothing but sine of x square. So you should understand that we are only going to apply this concept when composite functions are given to us. Now once it is given in this manner, how to do it? So what we are going to do is, if I want to differentiate this function, so dy by dx can be written as nothing but d by dx of sine of x square. Now see, we know the function or the differentiation of nothing but sine x, but we don't know that for sine of x square. So the trick lies in understanding that instead of x, we will multiply and divide by d of x square. So you can see that now whatever is written here, the same derivative we are doing, and in order to balance things out, we are multiplying by dx square and dividing by dx. So this expression, you can see that this is Leibniz simplification. This part will simplify to d by dx only. And by doing this, you have done this question. So differentiation of sine x is nothing but cos. In place of x, we'll write x square. Differentiation of 2x x square becomes 2x. Answer. So what we are saying is, now what we are doing in a general sense is basically what we put x square is equal to u. So when we are finding d by dx of sine x square, what we are doing is d by dx of sine u, and this we cannot find. So what we did was we multiplied and divided by du. So this became sine d by du of sine u, and then du by dx. Then we substituted the value of u here, that is nothing but dx square by dx. Now we can see that whatever is the variable in the denominator, same kind of variable is coming in the function as well. So this differentiation we know, we can put the value and we can get the answer. So if I do the first part, it becomes cos of u. If I do the second part, it becomes 2x. The cos of u can be written as nothing but cos of x square, and this becomes 2x, and this is same as what we figured out earlier. So this is the underlying principle or the theory behind it. In most of the cases, we won't have to write such a detailed answer, but if you know the steps, it is always better in the exam. If I look into this 2023 question, this question talks about, you can see that inside a function there is another function. So this is composite function. Whenever you see any kind of a composite function, then you should think about applying chain rule. But here you can see that there are three functions into place. So if I want to do this dy by dx, how will I do it? So when you're differentiating this function, I will give you simple logic. For objective questions, it will make your life extremely easy. So first, write the differentiation of log x, that is nothing but 1 by x. But in the place of x, there is not x. So whatever is in place of x, write that. E raised to the power, sine of e raised to the power x, we can write. Then you can see that next is nothing but sine x. So write the derivative of sine x, that is nothing but cos x. But instead of x, there is e raised to the power x. So write e raised to the power x. And in the third part, what we want to write is differentiation of this e raised to the power x. That comes out to be e raised to the power x. So you can see that your answer becomes nothing but cot of e raised to the power x into e raised to the power x. Let us see which option satisfies. So option C will satisfy. So the extremely simple question and extremely simple logic in applying it. So what you will do is you will start with this function, differentiate, then differentiate the next function that is inside, and then differentiate the third function. And then whatever is in the place of x, write that function in the ultimate answer. If I take this next question of 2023 once more, we will again differentiate dy by dx. Now we will have to differentiate this function. So instead of x, see, if it had been x square, the answer is very simple to be written. But you can see that instead of x, there is some other function written here. So what you can do is you can take x plus root of x square minus 1 is nothing but t. Now I am writing the subjective way of representing the answer, because that is important at the level of boards. You can see that what we have to find is the value of dt square here by nothing but dx. So what we will do is, in order to simplify the life, we will multiply and divide by dt into dt by dx. And this is what we need to find. Now this is very simple to find. Why? Because the first function, if I write, this is nothing but dt square by dt, very simple to calculate. And now the second bit, we can put the value of t, that is x plus root of x square minus 1. Now this is simple integration, we can do it. The first part becomes nothing but 2t. The second part will become nothing but 1 plus 1 by 2 root x square minus 1. And then differentiation of x square minus 1, that is 2x. If I simplify it further, I will put the value of t here, that is nothing but x plus root of x square minus 1. And if I take my LCM, you can see that this 2 will get cancelled out. This will also become root of x square minus 1 plus x by root of x square minus 1. So this is our answer for this question. Now you can see that the question does not end here. What they have written is basically answer we have given in a completely different form. So we'll have to do something more. So this was my first part. Now I have to do some kind of manipulation to reduce it in the form that is given to be in the question. So now you can see that a pattern that here dy by dx, what it is coming, that we need to observe. If I take my dy by dx, this 2 is fine. Root of x square minus 1 is also fine. But this part, what we are getting is nothing but x plus root of x square minus 1, same thing. So you can replace this by nothing but 5. So this substitution makes my life very simple, because once I have done the substitution, I can square both the sides. If I square, it is dy by dx whole square is equal to 4y square by x square minus 1. So I can take x square minus 1 on the other side. It becomes x square minus 1 dy by dx whole square. And this is equal to nothing but 4y square. If I look into what was asked, this was exactly the same expression that was asked to us. So I have proved the above statement. Now this type 5 talks about implicit form or differentiation of implicit function. What does implicit function means? See, if I write all the values of x and y separately on both the sides of the equation like this, it is nothing but an explicit function. But if I jumble up the values and write the same expression as x minus y plus 2 equal to 0, you can see that x and y are both on the same side, then this is known as implicit. This is what we mean by it. Now, what we need to understand is first part we have already been doing. Second part, we need to understand how to handle them. So if I start with this 2017 question, let us see how to handle such questions. So if this is given to me, so either what I can do is make it explicit, that is one thing, or I can differentiate both the sides. That is also a valid way of doing it. So what we can do is we can directly differentiate both the sides. So if I do that in the first step, let us see what I get. What I get is nothing but difference product rule I will apply. So d by dx of e raised to the power y into x plus 1 plus e raised to the power y into d by dx of x plus 1. Differentiation of a constant becomes 0. Once I have done this, derivative, this first part will be e raised to, we are applying chain rule, and then derivative of y will become dy by dx. This is very important to understand. Again, what I'm doing, differentiation of e raised to the power x, but x is not there, y is there, so derivative of y should also come. Chain rule we are applying. So once I do this, this part is very simple. It becomes e raised to the power y into 1 is equal to 0. Now you can see here that I can cancel out this e raised to the power y from both the sides. So what I've got is dy by dx plus 1 by x plus 1 is equal to 0. Now this is what we are getting. Now if you simplify it by one more step, I can write dy by dx is equal to minus 1 by x plus 1. Now this is not what they want. What they want is the value of second derivative. So in order to find the second derivative, we'll have to differentiate one more time. And if I do so, d2y by dx square will be nothing but, now again chain rule, 1 plus x plus 1 whole square, and then derivative of nothing but x plus 1. So again we have chain rule once more. So chain rule is very important, would be used in multiple questions. Now your derivative of x plus 1, and here it will be plus sign. Plus. The derivative of x plus 1 becomes 1. So now again, if I compare both the sides from here, I can substitute the value of 1 upon x plus 1 here. And if I do so, d2y by dx square would be equal to nothing but dy by dx whole square. And this is what was asked in the question as well. And that we have got that expression. Let us see one more question of 2018. This question talks about, again, we have implicit function x and y is mixed on both the sides. Again, we can apply the same technique. So if I differentiate on both the sides, I should ideally get my answer. Not square. So once I've written it in this manner, I will differentiate. So again, you will have to apply chain rule. So 2 times x square y square. So we are treating it like x square. So differentiation of x square is nothing but 2x. So we have written that. And then we'll have to differentiate nothing but x square plus y square. And the right hand side can be written as d by dx of x into y plus x into dy by dx. This is how we'll do it. Once I've done that, you can see that this is 2 times x square plus y square. Whatever is inside, and it will also get distributed. So this becomes d by dx of x square plus d by dx of y square. The derivative of x is nothing but 1. This will become x dy by dx. If I simplify this, again it becomes a very simple thing. So if I simplify, derivative of 2x, x square becomes 2x. Derivative of y square becomes 2y dy by dx. Again chain rule we have used. Y plus x dy by dx. Now you can see that we have got dy by dx on both the sides, and this will always happen in the case of an implicit function. What we need to do is bring both of these terms of dy by dx on the same side. So in order to do that, you'll have to open the bracket, and if you open the bracket, this will become 4x square y square x, and then 4x square plus y square into y dy by dx. On the right hand side, it is y plus x dy by dx. If I want to simplify this, it is a very simple thing, or in the next step we can easily simplify. So let us write this as 4x square y plus 4y cube. If I take this x divided by dx on the left hand side, this will also get subtracted. Dy by dx we can take common. So this will become nothing but equal to 4y minus 4x square plus y square into x. And if I find the value of dy by dx from this side, it comes to be y minus 4x cube minus 4y square x divided by 4x square y plus 4y cube minus x. Now this is the answer that we are getting. So you can see that such questions will be little bit complicated in terms of calculation, and you can also check I might have also missed out to something, but you should understand the process. You differentiate both the sides. Once you have differentiated both the sides using chain rule, we take dy by dx on the one side and all other terms on the other side. And another thing to notice is in the answer will not be there in just in terms of x, y will also be there in the answer. And this is something very peculiar for implicit differentiation. Now, if I look into this sixth problem type, it is higher order derivative. So instead of differentiating one, we will have to differentiate 2, 3, 4, 5 n times. This is known as higher order derivative. I will take an example. So in this 2018 question, you can see that what they're asking is the second derivative also. We also did that in one question before, but again, we are doing it. So what you need to do is you need to differentiate it once. There are two ways to do it. I will show you both the methods. So first is you differentiate it once. So again, you are using chain rule. So this becomes cos of sin x, and then differentiation of sin x, that will again become cos x. So we have used chain rule here. Once you have written this, what they're saying is you have to differentiate one more time. So what we can do is we can differentiate this once more. So if I differentiate it once more, you can see that it has become second derivative, d2y by dx square. See, d2y by dx square does not means it is equal to dy by dx whole square. So, and this mistake also I've seen student doing. So this is not equal to dy by dx whole square. Now, this is separate and the other one is separate. Both of these are different ideas. You need to be very careful regarding this. What they're asking. Now, if they're asking this, if I differentiate once more, you can see that there are two terms, 1 and 2. So we'll have to use our product rule. So d by dx of cos of sin x into cos x and plus cos of sin x into d by dx of cos x. So if we do the first part, we can apply again chain rule. So cos x differentiation is nothing but minus sin x. So this becomes minus of sin x, and then differentiation of sin x, that would be nothing but cos x. And then we have already one cos x waiting for us. And then again this part will write as it is, so cos of sin x. And then differentiation of cos x is nothing but minus sin x. This is what we are getting. If you simplify this, and this is very important for us to understand something also, and rearrange the term, this will bring in the forward, in the earlier part. So what I can do is I can write this as minus sin x into cos of sin x. And this is first term, and I have changed the order. This I have written in the first part, and whatever is written in the first part we can write in the second part. So this becomes nothing but cos square x into sin of sin x. This is what we get. Now we can see that our answer is not matching. So for matching the answer, you will have to resubstitute terms. So what you can do is you can take this dy by dx value and substitute the value of cos of sin x from here. So if I find cos of sin x from here, you can see that it is nothing but dy by dx by cos x. And if I put this value here, you can see that it becomes minus of sin x into dy by dx by cos x. And then I'm getting nothing but cos square x into sin of sin x. So now this sin x by cos x can be written as tan x, and now we have got our answer. So minus of tan x dy by dx minus cos square x into sin of sin x. So now if you look into the question, and all we need to do is bring all the terms on the left hand side. Again, this term that we have could also have been substituted in terms of y, because if you look into the question, this was the question. This is y. So if I put here also replace this by y, this will become again very simple. And now what we need to do is bring all the terms on the left hand side. So what we get is d2y by dx square plus 10x into dy by dx. And then also bring this into left hand side plus cos square x into y equal to 0. So you can see that now whatever we are getting, this is matching the thing that is given in the question. So we have proved the above statement. So you can see that we'll differentiate and substitute. So there are two steps. First is differentiation. And then what we did was nothing but substitution. So there are two steps that we need to do. And since they are asking about higher derivative, we'll have to differentiate two times. Now there is one more technique to do the same question. So instead of, see what we will again start with the same differentiation that we did earlier. So it will become cos of sin x, and then differentiation of sin x is nothing but cos x. This we have. Now what you can do here is basically take this cos x on the left hand side. If I take it on here, this side. So what will happen is this will become dy by dx by cos x is equal to cos of sin x. Now what we can do is we can write this as nothing but sec x dy by dx. And this is the very famous technique because this will avoid some substitution. I'm not saying every substitution will get avoided, but some substitution we can avoid by just taking one term on the left hand side. Once you do this, and now if you differentiate both the sides, so dy by dx into sec x into dy by dx, and then d by dx of nothing but cos of sin x. If I perform this differentiation, let us see what do I get. If I do so, again we will apply chain rule. So quotient product rule. So dy by dx into sec x, and then d by dx of dy by dx. This is dy by dx we will get. And then what we have is basically one more term. We will have sec x. So we are using the formula of u v dash. So u dash v plus u v dash. That is what we are doing. Then derivative of the next part, that is dy by dx. And on the right hand side, what we are going to get is the differentiation of this part, that is nothing but minus of sin x, and differentiation of sin x, that is nothing but cos x. This we can do. Now once you have done this, let us see what is the differentiation of the first part. Can be written as nothing but sec x tan x into dy by dx. This is the first part. If I look into the second part, it will become sec x into second derivative or d2y by dx square. And if I look into the right hand side, you can again substitute this sine of sin x as nothing but y. So this becomes minus of cos x into y. You can see that if I multiply by cos x on both the sides, I get my answer. So if I do so, it becomes d2y by dx square plus tan x dy by dx, and then this will become nothing but minus y I can bring on the left hand side, and I've got my answer. So what is the important thing that we did? Most of the things are same. Only thing that we are doing differently is we are taking this cos x on the other side, and by doing this and then differentiating, one substitution we are able to avoid. So that number of substitutions have become less if I use this technique. If I move forward in this 2014 question, let us see what they are saying is, again we'll have to differentiate twice. This is what they're asking us to do. So let us do that exactly what they're asking us to do. So let us find the value of dy by dx. It becomes nothing but p of, now if I differentiate this, e raised to the power ax would be there. Then q d by dx of e raised to the power bx would be there. If I actually do this, what am I getting? I'm getting p times, this will become e raised to the power ax, and differentiation of ax is nothing but a. Again, chain rule. E raised to the power bx and differentiation of bx is nothing but b. This is what we are getting. So this is nothing but the value of dy by dx. So if I differentiate the same thing one more time, so now what we can do is differentiate one more time. So if I differentiate one more time and find the value of d2y by dx square, becomes p into e raised to the power ax, again differentiation of this part, plus q into d by dx of e raised to the power bx. And also 1a and 1b that we got earlier, we also need to write that. Once we do that, again it becomes nothing but a into p into dy by dx of this is nothing but e raised to the power ax. Differentiation of ax is nothing but a. This is b into q. And differentiation of bx is nothing but e raised to the power bx into b. That becomes b square. So it is nothing but a square p e raised to the power ax b square q e raised to the power bx. Okay, this is what we are getting from here. Now we have got all the ingredients right. Now in the next step, what we can do is nothing but in the LHS part of whatever is given to us, we'll put the value of d2y by dx square from here. We'll put the value of dy by dx from here, and we will put the value of y from here. Now, these three substitutions we'll do, and let us see what happens. So the value of d2y by dx square is nothing but a square p e raised to the power ax plus b square q e raised to the power bx minus a plus b into nothing but ap e raised to the power ax plus bq e raised to the power bx, and then the last part, that is ab into y, that is p e raised to the power ax plus q e raised to the power bx. Now if you simplify, the calculation is not difficult, it will come out to be same. So here we have used direct substitution because there is no way around it. If I look into this 2016 question, we'll have to use the earlier technique, what we used one question before, that technique only. So if I differentiate this, again I will have to write the derivative of the first part to 2 sine 2 dy by dx cos of log x will have to write, and then 3 times d by dx of sine of log x also I will have to write. If I do this, I will have to apply chain rule, so this becomes minus of sine of log x, and derivative of log x is nothing but 1 by x, so we have used chain rule. In the next part also we'll have to do the same. Differentiation of sin x is cos, but instead of x there is log x, so we'll write log x. And then differentiation of log x, that is 1 by x. Once we have written this, in the next part you can see that if I take intelligently this 1 by x on the other side, my life will become easy in the next differentiation cycle. And what I'm getting is nothing but minus 2 sine of log x plus 3 cos of log x. So now again I will differentiate in the next step. So if I differentiate in the next step, it becomes d by dx of x dy by dx. So what we will have to do, we will have to use the product rule here. And then this becomes minus 2 d by dx of nothing but sine of log x and plus 3 times d by dx of cos of log x. We have already done this differentiation once, so I will be doing it faster. So minus 2 times cos of log x, differentiation of log x is 1 by x, and then plus 3 times differentiation of cos x is nothing but minus sine log x into 1 by x. What we have written on the left hand side, let us also write the differentiation of that part. So if I do it, what I'm getting from here is nothing but this will become x ka differentiation, that becomes 1 dy by dx. You can write 1 or 2 steps more here. I am doing it little bit faster. And then dy by dx is nothing but d2y by dx. You can see that just by taking that one on the other side and again differentiating, our life has become very easy, and this is a very useful trick in solving such questions. So if I simplify and write one more step, this is x times d2y by dx square. I've rearranged the terms plus dy by dx. And now if you take minus 1 by x common from here, this becomes 2 times cos of log of x plus 3 times sine of log of x, and this is nothing but equivalent to the original statement that we wrote. So if you look into the question, this was nothing but the value of y. So you can substitute the y. So if I do that, what I'm getting is x d2y by dx square plus dy by dx. This becomes minus 1 by x into y. Simplify, so x square d2y by dx square plus x dy by dx plus y would be equal to 0. This is the answer that we are getting. If I move towards type 7 problem, it is nothing but based on logarithmic differentiation. Now, logarithmic differentiation means either differentiating the logarithmic function or using log to find the answer. So when you will use this, there are three use case scenarios when log is directly involved in the question. Second, there is some variable power. What do I mean by variable power? Some we have x raised to the power y, or y raised to the power x, or x raised to the power sin x, and such kind of question. Wherever you find this, you will have to apply this. And there is a third use case scenario when lot of multiplication is happening. So there are these three use case scenarios of this application. We will see what kind of questions were given in the board exams. But these three things, if they are happening, multiple time terms getting multiplied, variables in the power, or log is directly involved, then we will use this kind of a scenario. Now let us understand this. You can see that here there is a variable in the power. So what you are going to do is, in such question, directly we cannot differentiate. So first take this x raised to the power y as u, and v as nothing but y raised to the power x. Why are we doing this? Because if I do this, then the question can be rewritten. So u plus v will be equal to a raised to the power v. What is the benefit? So if you differentiate this, the derivative will get distributed. And now what we have is nothing but a very simple thing. Derivative of u with respect to x plus derivative of v with respect to x is equal to 0, because this is a constant term. So now our life will become easy, because direct log we cannot apply or a positive sign. So this we have done. Now in order to do this, we can take log on both the sides. So log of u will be equal to log of x raised to the power y. If I do it for the first part, I can write this as log of u is equal to y times log of x. And now if I differentiate both the sides, what I have got is nothing but d by dx of log u is equal to d by dx of y log x. So if I differentiate the left hand side, it becomes 1 by u and then derivative of u with respect to x. Here we'll have to apply product rule. So d by dy by dx into log x, and then plus y times d by dx of log x. If I simplify, what am I getting? The first part becomes 1 by u du by dx. Derivative of y is nothing but dy by dx only into log x. And the second part becomes y into derivative of log x is nothing but 1 by x. So from here we can find the value of du by dx. It is nothing but u into dy by dx into log x plus y by x. So this is what we are getting, and u you can substitute as nothing but x raised to the power y. In the second question that is given to us here, and again we can use the same technique. So what I am going to do is again use the same technique. Take log on both the sides. So log of v is equal to log of y raised to the power x. This can be written as log of v is equal to x log y, and then differentiate, so it becomes nothing but 1 by v into v dash, or dv by dx. I am doing it faster because I have already done it once. We are using the same technique twice, and here we'll use the product rule. So this becomes 1 into log y plus, this next part can be written as x into derivative of log y would be equal to 1 by y dy by dx. So if you want to write the value of dv by dx, the v will go on the other side, and v can be written as nothing but y raised to the power x. And what we have got is nothing but log y plus x by y dv and dy by dx. You can see from here is we have got the value of du by dx, we have got the value of dv by dx. So now both of these values can be substituted in the first part that we figured out. So if I substitute the value, what am I getting? X raised to the power y into dy by dx into log x plus y by x plus y raised to the power x. Now we are putting the value of dv by dx into log y plus x by y dy by dx. So if you have got this value, now you can see that this is equal to 0. We can separate the dy by dx term. And so what we need to do is separate this term on one side and push all the terms on the right hand side and simplify and get an answer. So if I do that, what am I getting? So you can see that dy by dx, if I keep it here, I will have x raised to the power y into log x, and then from the other part I have y raised to the power x into x by y, and the other terms, if I push on the other side, they become nothing but x raised to the power y, minus term would be there, into y by x plus y raised to the power x log y. If I want to find the final answer, what will be the final answer? If I want to find the final answer, the value of dy by dx, it comes out to be minus x raised to the power y by x, and this can be again simplified, written as nothing but y minus 1 into y plus y raised to the power x, and here also we can write the minus sign, into log y, divide by nothing but x raised to the power y log x plus y raised to the power x by y. This y we can also absorb here, right? X minus 1, y raised to the power x minus 1 into x. So this is the answer that we are getting. You can see that it has 3 different steps. First is assuming this x and y. If you do not do that, you will not get the right answer. So this is the first part that we did. This was the first step. Next, what we did was we figured out the value of du by dx by differentiating this and this we did using the logarithmic differentiation. Now, if I look into this next question, it is based on similar type of concept. So let us divide it into 3 parts. Now what we'll do is, again we'll assume u as nothing but x raised to the power sin x. And then we will take the value of v as nothing but sin x raised to the power cos x. And in the third part, let us write what they have given us in the question. So what we can write, if I take this function as y, then y can be written as nothing but u plus v. So if I want to find the value of dy by dx, it is nothing but du by dx plus dv by dx. This is what we need to find, and this is what the question is asking us. So now, if I do this, the first part, differentiation, I will have to find. Second also I will have to find. I will substitute both the values in the third part and get my answer. If we look into the first part, what I'm going to do is I'm going to take log, because there is variable in the power. So log of x raised to the power sin x we can do. This can be written as nothing but log of u is equal to sin x log of x, and then we will differentiate. The left hand side, if I differentiate, it becomes 1 by u into du by dx, and right hand side, the differentiation of first function, that is nothing but cos x into log x, then sin x into differentiation of log x, that is nothing but x. This is what we have done. Once you have done this, the value of du by dx comes out to be u into cos x log x plus sin x by x. And if I do that, the value of u we can put as nothing but x raised to the power sin x into cos x log x plus sin x by x. So we have figured out the value of du by dx. Similarly, we can do the same exercise for v. So if I take again log of v, this is nothing but log of sin x raised to the power cos x. Cos x can be taken outside, so it becomes cos x log of sin x. And if I take this value and differentiate both the sides, what I get on the left hand side is 1 by v dv by dx. On the right hand side, the differentiation of first part will come, that is minus sin x into log sin x, and then differentiation of log x will come, that is 1 by sin x, and differentiation of sin x will be cos x. This is what we are getting. And if I simplify just one step more, I will get the value of dv by dx, and that comes out to be nothing but v into This can be simplified into minus sin x log of sin x. And then cos x into cot x. Or cos square x by sin x. So the next step is very simple. All we need to do is take this value of du by dx and substitute in the earlier part. And if I do so, I am getting a slightly big answer, that is x raised to the power sin x into cos x into log of x plus sin x by x. And the second part comes out to be nothing but v, that is nothing but sin x raised to the power cos x multiplied by minus sin x log of sin x, this part, plus cos square x by sin x. This is what we are getting. So this is exactly like the earlier question, and little bit simplified version of the same kind of question. If I look into the next question, you can see that we have been again given the same kind of question. Now I think you can again take this u as nothing but e raised to the power x square sin x. V is nothing but cos x raised to the power x. And if I want to find the value of dy by dx, it would be nothing but du by dx plus dv by dx. Again, I can apply logarithmic substitution in the first and second part, get the answer, substitute the value, and get the answer of this question as well. So it is not a difficult question, similar kind of questions. If I move to type 8, it is nothing but parametric form of differentiation or parametric differentiation. Sometimes a function x will also be given in terms of some other parameter like sin, like t. So x is a function of t. Similarly, y is also given as a function of t like cos t. So what we will do is we can find this differentiation with respect to t, and this becomes nothing but cos t. We'll find the value of dy with respect to dt. This is nothing but minus sin t. And if I want to find the value of dy by dx, the answer is very simple. We will take this dy by dt and divide it by dx by dt. And if I do it, the first part becomes nothing but minus sin t, and the second part becomes nothing but cos t. So answer becomes nothing but minus tan t. So this is what we know is nothing but parametric differentiation. Both the values are given in terms of some other variable that we'll call as nothing but the parameter. So simplest example of a parameter is nothing but money. Everything is expressed in terms of money. But what is money? It is just a medium of exchange. Similar kind of things is happening here. Now, in this similar case only, if I want to find the second derivative, this is very important because this is where the students will get stuck. So what I will do is I will take this first derivative and then differentiate it with respect to y. This is what I'm going to do. And what I cannot do, that also I will tell. This is what I'm going to do. So if I take this, so d by dx and of here is nothing but minus tan t. If I do it, I will have to use chain rule. So answer becomes nothing but minus sec square t and then dt by dx. Now in order to find this value, I will have to substitute the value of dt by dx. And dt by dx from the first part was nothing but 1 by cos t. So dx by dt is nothing but cos t. And if I want to find dt by dx, it is nothing but 1 by cos t. So if I substitute this value here, and for dt by dx, I should get my answer. It is 1 by cos t. And if I put this value, it comes out to be minus sec cube t. And this is what the answer comes out to be. So you can see that what we have to do is we will have to follow this specific procedure in order to get the value of d2y by dx. So this is what we need to do. And dt by dx will come here. See what we cannot do, and this is very important, don't do this. Sometimes in order to get the answer, what students will do, will do weird things. What we need to do, we do not need to do is, if somebody wants us to find the value of d2y by dx in this case, it is not equal to, and this is very important, do not put this equal to, or it is not equal to dy by dt and then dx d2y by dt square and d2x by dt square. It is not equal to this, and this is very important to know. If I move further, now let us see what kind of question J asks us. So in 2018, there was this question. You can see that both x and y are given in terms of parameter here. So what we can do in this question is find the value of dx by d theta. So if I do that, it comes out to be nothing but a will be there. This will become 2 minus cos 2 theta into 2. Similarly, we can find the value of dy by d theta. And if I do this, it becomes a. This differentiation is 0. This will become plus sine 2 theta into 2. And then if I want to find the value of dy by dx, it is nothing but dy by d theta by dx by d theta. This is what we can do. So if I divide both of these values, what am I getting? A times 2 into sine 2 theta. And then dx is nothing but a times 2 minus 2 times cos 2 theta. If you do it or simplify it, what I'm getting is nothing but sine 2 theta by 1 minus cos of 2 theta. And what they have already given us, we have to find this value of theta equal to pi by 3. If I put theta equal to pi by 3, this is sine of 2 pi by 3. This will become 1 minus cos of 2 pi by 3. The numerator will be equal to root 3 by 2. Denominator is equal to 1 minus 1 by 2. So this is root 3 by 2 by 3 by 2 or 1 by root 3. So this is how I get the answer to this question. So again, very simple steps you can take to get to an answer. Now if I look into this 2016 question, again similar kind of structure is given and dy by dx is asked. What we can do is, again we can find the value of dy by dt. Now here you can see that in order to find this, I will have to do slightly more calculation. So this becomes sine 2t plus sine 2t cos 2t. This is what is given to us. So this is what we have to solve. Now you can see that the process is simple, just the differentiation is little bit more complicated. So we need to account for that. If we account for that, we'll get our answer. So we'll have to write 1 or 2 steps more. So the first part is find sine 2t. For doing this, let us do the simplification by multiplying and dividing by 2. If I do so, my numerator becomes sine 4t because sine 2 theta formula is getting formed. And now I can differentiate because differentiation has become very simple. So this becomes nothing but cos 2t. And differentiation of 2t becomes 2. This will become nothing but cos 4t. Differentiation of 4t becomes nothing but 4. This a is out of the bracket. Now if I simplify this, this is nothing but 2 cos 2t. This also becomes 2 cos 4t. So 2 we can take common and 2a times cos 2t plus cos 4t we will get. This is what we are getting in this question. Once you have done this, now in the next part what we can do is we can find the value of nothing but dy by dt. In order to find the value of dy by dt, let us again differentiate this other part. Also for that we'll have to simplify it first. So if I want to do that, b is fine, but cos 2t we will have to take inside and this will become cos square 2t. This is what we are getting. And now if I want to differentiate this, it will become b times d by dt of cos 2t is minus sine 2t into 2. And then for the next part, what I have is minus times 2 cos 2t. Differentiation of cos 2 is sine 2t into 2. This is what we are getting. Once you have figured out this value, in order to find in the next step, and so this was my first step. This has always been my second step. Now what we can do is we can directly put the value of t as pi by 4 here and then divide. That is also fine and that will make our life easy. So if I find the value of d by dt at t equal to pi by 4, let us see what happens. If I put that, this becomes cos of pi by 2. This will become cos of pi. And if I simplify, what I'm getting is twice of a into cos pi becomes minus 1. Cos pi by 2 is nothing but 0. You can see that this is again making our calculations simpler. This will also find that t is equal to pi by 4. If I put pi by 4, we can see that b part is fine. This becomes nothing but minus of 2 sine of pi by 2. And then minus is again fine. What we are getting is 4 times sine pi by 2 cos of pi by 2. So the second part will become 0. And what we are getting is nothing but minus 2b from here. And what we get earlier was minus 2a. So if I divide it, because we want to find the value of dy by dx in the third part, So we will divide this dy by dt by dx by dt, and if I divide it, it becomes minus 2b by minus 2a, or b by. This question can be solved in a much simpler way. Now, if I eliminate the t in the first place, so what I'm doing is I'm eliminating t. I'm eliminating the parameter. So what we can do is we can take the value of t from here, the second equation. So if I find t, it is nothing but y by 2a. And put this in the first equation. So x is equal to a times y by 2a whole square. And if I do so, it becomes x is equal to a into y square by 4a square. So you can see that from here, y square is equal to 4ax. This is what we are getting. Now this is very interesting to find, because if I want to find the second derivative, what I can do in this case is I can differentiate it. So 2y dy by dx will be equal to 4a. So the value of dy by dx comes out to be nothing but 2a by y. This is what we are getting is 2 dy by dx. Now if I want to find the second derivative, we'll differentiate this one more time. And if I do this, this becomes nothing but minus 2a by y square into dy by dx. This is what we are getting. So once you have got this, now again I can put the value of dy by dx here, and that was nothing but 2a by y. So it is 2a by y square into 2a by y comes out to be minus 4a square by y cube. And this is my answer. So you can see that this approach was much simpler compared to earlier approach. And for board exams, this approach will work much better compared to the earlier approach. Now let us see this next question, that is 2015 question. We need to do the same thing here, eliminate the value of theta. So what I can do is I can square x, that will become a square cos square theta plus b square sine square theta plus 2ab sine theta cos theta. And then we can also square the other part, that is nothing but y square. So it becomes nothing but a square sine square theta plus b square cos square theta minus 2ab sine theta cos theta. And if I add both of these, what am I getting? What I get is x square plus y square is equal to a square cos square theta plus sine square theta plus b square sine square theta plus cos square theta. And the last two terms will get cancelled out. So what you can see is sine square theta and cos square theta is also 1. So your expression is coming out to be extremely simple. X square plus y square is equal to a square plus b square. See, now this is much simpler. This has become an implicit differentiation question and much simpler to do. So if I differentiate this, it is 2x plus 2y dy by dx is equal to 0, because the right hand side is constant. Now what they want is the second derivative. So what we can do is differentiate the same thing one more time. Before that, let us also cancel out this 2. So if I differentiate one more time, the differentiation of x becomes nothing but 1. The differentiation of this side, we'll have to use product rule. So derivative of y will become dy by dx. There was already one dy by dx. Then y into differentiation of second part, that is d2y by dx square equal to 0. So what we are getting as a result is y times d2y by dx square plus dy by dx whole square plus 1 equal to 0. Now this is what we are getting. Now this is like very simple question if you do it in this manner. If we do it from the earlier method, it will become extremely lengthy. So eliminate the parameter and solve such questions. If I move towards the last or the ninth problem type, it talks about differentiation of inverse trigonometric functions. Okay, so now here you need to know this 3-4 results. One is d by dx of sine inverse x is nothing but 1 by root of 1 minus x square. The d by dx of cos inverse x, that is nothing but minus 1 by root of 1 minus x square. D by dx of tan inverse x, that is nothing but 1 upon 1 plus x square. Usually these 3 would be enough, but you can remember one more, d by dx of sec inverse x, that is nothing but mod of x root of x square minus 1. Corresponding to this, we have one more result, that is cot inverse x. And you can see that if I am writing cot inverse x, answer comes out to be the same as tan, but only minus sign is different. Here also the answer was same, only minus sign was different. And for cosec inverse x, dy by dx cosec inverse x is nothing but the same as above, just a minus sign will come. If I remember this 5-6 result, largely I will be able to solve questions. Now, when we are solving the questions, another thing that we need to do is substitution. First we will substitute, then we will simplify, and then we will differentiate. These process we are going to follow in order to get to an result. Now let us see what kind of questions were made on this idea. This 28th question talks about differentiation of this function. So y is given as nothing but tan inverse of 1 plus cos x by sin x. So what we can do is first we can simplify. Substitution we do not need to do because everything is term of trigonometric ratios only. So how will we simplify this? The part, first numerator part. See, now for cos x, there are two formulas. One is 2 cos square x minus 1 and x by 2 minus 1. So if I take one on the other side, we get a very famous formula, 1 plus cos x is equal to 2 cos square x by 2, and this is one such result that will be used a lot in calculus. So if I put it here, it becomes a 2 cos square x by 2. Denominator can be written as 2 sin x by 2, cos of x by 2. Cos x by 2 we can cancel out, we can also cancel. So what we are getting is tan inverse of cot x by 2. Now in order to simplify this, we have a result that tan inverse of x plus cot inverse of x is equal to pi by 2. So what we can do here is we can put the value of tan inverse x in terms of cot inverse x. So I can write this as pi by 2 minus cot inverse of cot x by 2, and we can write this as nothing but x by 2. If I do this, this is the value of y. Now we can very simply differentiate. If you differentiate, the answer comes out to be minus 1 by 2. So this is a question in which we were able to simplify. So this was simplification, and then differentiation was very simple. So if you do not simplify, then differentiation becomes lengthy. If I look into this next question of 2015, again I have to substitute. So here the first step is coming, that was earlier not there, substitution. So we can put the substitution of x square as nothing but cos of 2 theta. Now what is the benefit of doing so? Now we will be able to utilize these two formula, 1 plus cos 2 theta, that is nothing but 2 cos square theta, and then we will be able to use the formula of 1 minus cos 2 theta, that is nothing but 2 sin square theta. These two formula we will be able to utilize. If I do that, now let us see what happens. So the value of y will come out to be tan inverse root of 1 plus cos of 2 theta plus root of 1 minus cos of 2 theta divided by 1 plus cos of 2 theta minus root of 1 minus cos of 2 theta. What we are getting here is a very interesting thing. And once you have got this, we can simplify this. So it will become tan inverse of root of 1 plus, this becomes 2 cos square theta. This becomes 2 sin square theta divided by root of 2 cos square theta minus root of 2 sin square theta. Now here also what you can see is basically this root 2 we can cancel out. Now once I do this, what I can observe is this root of x square will be nothing but mod. So if I do this, this first part can be written as tan inverse of, this becomes mod of cos theta plus mod of sin theta by mod of cos theta minus mod of sin theta. And if I do this, in the interval that is given to us, I can remove this mod signs. This will become cos theta plus sin theta by cos theta minus sin theta. Because in the interval that is given to us, this mod will open with a positive sign. Once you do this, I can divide this by cos and it becomes 1 plus tan theta, sin theta by cos theta. This we did earlier as also, similar kind of expression. And then what we did earlier was nothing but write this 1 as nothing but tan pi by 4 plus tan theta upon 1 minus tan pi by 4 into tan theta. And once I write it down, this is nothing but tan inverse tan of pi by 4 plus theta. And this we can write as nothing but pi by 4 plus theta. Now theta, if I go back to the original substitution, is nothing but x square is equal to cos 2 theta. So if I look into this theta part, theta or 2 theta can be written as nothing but cos inverse of x square. So theta is nothing but 1 by 2 cos inverse of x square. This is very important. So once you have understood this small part, you can substitute the value of theta. It is nothing but 1 by 2 cos inverse of x square. Now we can differentiate both the sides. So if I differentiate dy by dx, the first part becomes 0. 1 by 2 is fine. Differentiation of cos inverse x is 1 upon root of 1 minus x square. And x square ka square will become x to the power 4. And differentiation of x square becomes 2x. If I simplify this, I get my answer. That is very simple too. In this video, we talked about 9 problem types based on continuity, differentiability, and differentiation. I hope you liked the video. I tried and completed all the important problem types. If you focus on these problem types and the homework that is given after this, largely speaking, you will be able to cover a large array of questions, and largely your board exam paper will be out of these questions only. If you like this video, you will also like Pragbee's unique approach to teaching students or guiding students for the last mile journey. So if you are a student who has been preparing for 2 years and going to write this exam in 2024, this is one of the best ways and platforms that you can prepare with. Unlike other crash courses who focus on teaching 100% syllabus in just 2 to 3 months, which a student took 2 years to prepare, we have a different way to approach the problem. This process works on 3 very specific steps. In step 1, we start from you. What exact preparation have you done in the last 2 years, last 1 year, last few months? And what is the minimum amount of effort, areas, concepts and problems that required to be prepared to get a very good college from JEE Mains? In step 2, based on this customized plan that was prepared based on your strengths and weaknesses and the minimum path of least resistance that you can take to get into a very good college, we align you a one-on-one faculty, a faculty who is going to teach you as a student, keeping your needs into mind, where you are getting stuck in a topic, what kind of problems you cannot solve, and how to solve those problems in a very efficient and smart manner and convert that topic into tangible marks in JEE Mains. In step 3, we attach you to a test series, a testing platform where you can test yourself for each and every topic that you're preparing. You can write full syllabus tests and get an understanding that how this program is working for you, wherein the faculties can again sit with you and customize the plan based on your needs so that your score is getting maximized in JEE Mains exam. Using this program, Ashish was able to maximize his score in JEE Mains and JEE Advanced and was able to get into IIT Madras Mechanical in just a matter of 3 months. If you are one of those students who think that he has got the potential, who can make it, and he wants to have a smart and efficient approach at this point of time, which can maximize his or her result in JEE Mains exam, you can apply for this program in the link given in the description, and somebody from my team will get in touch with you and help you out. See you until next one.